Okay, welcome Foundations Pre-Calculus 10 students. We're going to start off Unit 1 here. I am Mr. Tronis, and let's follow along and get our first set of notes done. So just to review what we're going to be going into here, we have 5 sections total. This will be Unit Section 1.1, our first set of notes on powers and roots. So let's get right into it. This should be review. So we're just going to be labeling a few things, understanding powers are repeated multiplication of a base. Well, what is the base? It's this big number 5 in this example. So that is called our base. Up here on the top right in the superscript, this is called an exponent. And this is telling us how many times we're going to multiply the base. The whole thing here, the box, is essentially called a power. And so if we were to expand this out, we would write this the long way as 5 times 5 times 5 times 5. So repeated multiplication, saying we multiply this 5 3 times over. So again, this whole piece is called repeated multiplication. And we can see a lot of parallels here actually with multiplication is also on its own repeated addition. So it's the same kind of idea, but now we're just repeating the multiplication, and we could evaluate this out. Of course, 5 times 5 is 25 times another 5 gives us 125 total. Okay. And there are some key numbers that we want to familiarize ourselves with, the following powers, so that we can evaluate them without a calculator. Now, this chart will always be provided for you, but over time, you're going to start to memorize these numbers and their importance. So down on the left here, n is representing our digits 1 through 12. And now we're going to square all those. And what that means is I take n, whatever it is, and I'm going to square that. So of course, 1 squared is going to equal 1. 2 squared is going to equal 4. 3 squared is going to equal 9, and so on and so forth. So we're going to fill in all of our squares here. They're actually called a special name, perfect squares. So 4 squared is 16, 25 for 5. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 81, 100. Let's scroll down a bit here. 121 for 11 squared, and 144. And that's going to be high enough for our perfect squares. So I want to make a quick note of that. These are what we call the perfect squares. And these numbers are really important. And when you see 1, 4, 9, 16, and so forth pop up in different types of questions, you're going to start to recognize them, and they're special. You're going to be able to do some special things with them because they have this unique attribute of having a number times itself equal them. So now we're going to move on to the cube. So again, this is just 1 to the 3, or 1 times 1 times 1, which is 1. 2 to the 3, which is 2 times 2 times 2 is 8. And we'll continue down. 3 to the 3 is 27. 4 times 4 times 4. So I'm just taking the 16, multiplying by 4 more, is going to give me 64. And 5 squared is going to give me, we did that up above, is 125. Now, we don't need the rest of these grayed out ones. We're not going to see them very often. But one to commit to memory definitely would be the 10 here. So again, multiplying 100 by one more 10, or 10 times 10 times 10, is going to give you 1,000. And let's move back up. We're going to do a couple of the n to the 4th and n to the 5th. So again, all we're doing is repeating the multiplication, this time 4 times. 1 still stays 1. 2 to the 4 becomes 16. And 3 to the 4 is going to give us 81. And let's finish this off. We're going to get 1 again, and we multiply 2 one more time. We're going to get 32. So those are very special numbers that we're going to see come up time and time again. And I'm just going to add these because you're going to see these once in a while. We're going to see 10,000, and you might even see something as high as 100,000. But all of those are perfect squares. Okay. One other thing too is we do have a special name for the cubes, and it's just like perfect squares. We call them the perfect cubes. Perfect cubes. Okay, now let's check out some of these. One really common mistake students make is being really careful with the negatives. So here we have 4 being raised to different exponents, and we're going to look at these a little more closely. So notice this first one is in brackets. And what that means is this 2, this exponent of 2, is attached to the 4 and the negative. So if I were to write this in expanded form, it would be -4 times -4, meaning there are 2 negatives, or the negative is being squared as well. So we know when we multiply 2 negatives, we get a positive. So we have a positive 16 overall. If we go over to the right here, we notice there are no brackets. This 2 is only attached to the 4. So if I expand this out, there's actually a -1 multiplying out in front, or a coefficient we call that. And then we have 2 4s being multiplied. So in this case, we only have one negative, which makes our result a negative. So this will be -16 overall when we evaluate. And likewise down below here, again, we have brackets. So this represents -4 being multiplied 3 times. And when we have 3 negatives, that's an odd amount of negatives, tells us we have a negative result. So we're going to get -64 this time when we multiply out. And over here, we only have one negative, the -1 coefficient sitting out in front, and then we have 3 4s, but we'll actually get the same result because with an odd number of negatives, we still get a negative result. So this will be -64 as well. So really common mistake is remembering when there's brackets, you must uh, raise that negative to the exponent as well. If there isn't, the exponent is only attached to the 4, not the negative. Okay, and like all things in math, we're going to learn the inverse. So roots is doing the opposite of powers. So we're going to put in a few definitions here. This whole thing is called a radical. Okay. And this specific one's a cubed root, but you've probably heard of square roots before. The number inside of this root symbol, if I highlight it here in red, that's the root symbol there, or the radical symbol. What we're going to have inside is the radicand. It's whatever we're rooting. So radicand. And this little number up here, kind of like the exponent, but it's the opposite. We call this the index. Okay, and what would this actually represent? So what we're actually trying to do here is something, we're trying to do the opposite. So if we were to, um, what does this actually represent out loud? If we were going to say it orally, would be cube root of 125. So we'd say the cube root of 125. And it's really important to understand, okay, well, what is this actually asking us to figure out? Well, the idea is that we want to figure out what number multiplied by itself 3 times would result in 125. That's how we find the cubed root to go backwards. So we have to say what number multiplied, for short, multiplied by itself 3 times is 125. That's what it's really asking here. A short form that I really like to write this is just a question mark. Okay, we'll put that in a little box. What is this number raised to the power of 3 that would result in 125? So similar to how we often learn our division tables, you don't usually hear that term. We learn our times tables, but division tables is really just using our multiplication tables backwards. That's what we're doing here. So we can easily determine that, oh, we did it on the other page. It's 5. 5 must be the number that you multiply 3 times, 5 times 5 times 5 to get 125. Therefore, we'll do this 3 dot symbol. The triangle means therefore. The cubed root, okay, because we have a little 3 there, of 125 must equal 5. Okay, so this should be something new that you may not have seen before. You've probably seen square roots, but we're going to learn how to do roots of all kinds of numbers. And we're going to try some without a calculator. Now remember, we do have this chart as a resource to cross-reference things to see if we can utilize it where needed. So this first one, we're taking the square root of a fraction. Now, if the index is not is not written, it is a 2. It is implied to be a 2. So this is a square root, probably something you've seen before. And we're taking the square root of fraction. We can take the square root of the top and of the bottom. So now we're taking the square root of both of these. And remember, I'm going to write in the index of a 2. You don't have to, but you need to know it's there, that we're trying to find a number times itself twice that gives us 25. Well, if you can't remember, of course, we do have this chart. It's right here. Okay, 5 times 5 is 25. So I know the numerator is going to be 5. And the square root of 16, again, what number times itself twice gives us 16? Well, that's 4, and we're done. Okay. And let's try B. So this is a cubed root. So now this time, what number times itself 3 times is going to give me positive 8. And in this case, we don't need the chart. I think we can do this on our own, is 2, because 2 times 2 times 2 is 8. So I'm just going to write this just to make it clear, because 2 times 2 times 2 equals 8. Okay, which is the exact same as saying 2 to the 3. All right. Let's try something a little bit tougher. So now we have a cubed root of negative 64. Don't let that negative throw you off. Again, it's saying what number times itself 3 times gives you negative 64. Well, we know it has to be negative, right? And again, we can use because 3 negatives would result in a negative evaluated sum or product. And what number times itself 3 times? If you don't see it already, just roll up here. Let's look at our perfect cubes and see if we see this number anywhere. And it's right here. 4 times 4 times 4 is 64. So that is going to be, our result is 4. And you can always check this. Multiply negative 4 by itself 3 times, and you're going to get negative 64. Okay, so here's probably one of the most challenging ones we're going to see is we have a decimal and we're taking the 4th root of it. So what number times itself 4 times gives us 0.0016. So you got to know a little bit about multiplying decimals, but you could try a couple different things. We're just going to try something and see what the result is. So if I try 0.2 times 0.2, okay, if you multiply this out, you're going to get 0.04. And if you multiply another 2, you're going to add another decimal place. You're going to actually keep getting smaller and smaller and smaller as you multiply a number between 0 and 1, like 0.2, 0.5. If you multiply anything by decimal between 0 and 1, you actually get smaller. So we can see that we need here 1, 2, 3, 4 decimal places. So I must be 0.2 that I'm going to multiply 4 times. And you can check this easily by just multiplying these two numbers and then multiplying that by 0.2 and then by 0.2 again. So this is where we're going to be multiplying, but because I have 2 decimal places, I have to move my decimal over here. And that's why we're at 0.04, multiply by 2 again. And I'm going to get 800 and then another decimal. And then finally, we're going to add another times 0.2. And we have to move all of our, now we'll have 4 decimal places in total, but I'm going to get 16. So my result's going to be 0.0016. Now you see I have 4 decimal places. So this must be 0.2. The key here again is just count the decimal places. If I have 4 here, okay, if I have 4 decimal places going back here, I must be multiplying by 1 decimal place 4 times over. Okay. Finally, we got one last set of 3 questions here. You do need to learn how to use your calculator, and it's going to depend. You're going to probably need to ask me in class to help show you on your calculator. I don't want you using iPhones and Androids. You need a scientific calculator to do these questions because you won't be able to use your device on a test. And so you're going to have a multitude of different buttons that allow you to do these things. So you will always have a square root button. Okay. You will always have usually a cubed root button, and it could look like this. It could look a little bit of different variation on this. But when you want to do fourth or fifth or all kinds of different roots, it can look quite a bit different. It could look like where you have letters like an X and a Y here. You could have, sometimes I've seen little boxes like this. Okay, could see that. Another one that's going to look really strange because we haven't talked about fractional exponents is it looks like X raised to the power of 1 over Y. Very strange button, but these are usually second, sorry, they're usually second function, meaning you have to choose to use the second function of your scientific calculator. Okay. Again, something I can show you in class. You could read a calculator manual, but better if I can show you because every calculator uses different buttons to do these types of roots. Now, this is just a quick lesson in rounding, but we have a square root of 10. Okay, 10 is not a perfect square, so we are going to get a decimal here. I know it's going to be in between 3 and 4 because I know the square root of 9 and the square root of 16 is 3 and 4. So if we put this in a calculator, we are going to get 3.1622 and a whole bunch more digits, but that's all we need because we're going to be rounding to 3 decimal places here. So I just look at, and this dot above the equal sign means approximately or rounded. I'm going to round the third decimal place, so it's 162 because of the 2 here. Okay, and here you're going to need to use your cubed root button. Okay, again, probably looks something like so. And the way we're going to start this one off is we're going to get a negative 2.5. Yeah, you get negative 2.5198. 5198 and a bunch more digits. And again, we're going to round this. And because of that 8, we're going to round up the 9, which means we have to round up the 1 as well. So we get negative 2.520. Finally, this last one, you're going to need some help probably finding this button. How do you do the fifth root on your calculator? But if you do it and round it this way, you can check. You should get approximately 3.807. Okay, and that concludes our first lesson, and we'll see you in the next one.